Welcome to Thinkadium, where curiosity wins.
All right, let's just dive right into it. Welcome to this explainer. Today, we're tackling the factorial problem. Now, while this is a really foundational mathematical concept, you should know it's also one of the absolute most common Java coding interview questions asked by top tech companies. Honestly, if you're gearing up for a whiteboard interview, you need this concept completely locked down. Let's get started. Section 1, the factorial problem. What exactly is it? So picture this. You're in a technical interview, and you're handed this exact prompt. Write a Java program to calculate the factorial of a given number. To make things concrete, let's say our input is 5. If we build this correctly, our program needs to successfully output 120. But, what actually is a factorial? Just by simple mathematical definition, a factorial is the product of an integer and all the positive integers below it. In math, it's represented by an exclamation mark. So 5 followed by an exclamation mark literally just means 5 factorial. And that simply translates to 5 times 4 times 3 times 2 times 1, which of course equals 120. Moving on to section 2, logic and algorithm, breaking down the math before the code. Okay, before we even think about Java, let's slowly walk through this cumulative multiplication process, basically building it from the bottom up. We start with 1 times 1, which is 1. We take that 1, multiply it by 2 to get 2. Take that 2, multiply it by 3 to get 6. Then 6 times 4 is 24. And finally, 24 times 5 gets us to our target of 120. This is great because it brilliantly illustrates exactly how our total value updates after every single step of multiplication. So how do those manual math steps translate into a logical set of instructions for a computer? Well, here's our algorithm. Step 1, read the number. Step 2, initialize our factorial running total at 1. Step 3, start a loop from 1 all the way up to our target number, n. Step 4, inside that loop, multiply the factorial by the current number. And finally, step 5, store that updated result and print it out. Section 3, writing the Java code, translating logic to syntax. All right, step 1 is building the outer shell of the program. We declare our class with public class factorial, and right inside that we place our public static void main method. Why is this so crucial? Well, for absolute beginners out there, this main method is the exact starting point where Java begins executing your code. It's the front door. For step 2, we declare our variables. Int n equals 5 stores our input. Then we have long factorial equals 1. Now, pay attention here. Why do we start factorial at 1 and not 0? Well, think about it. If you initialize it at 0, every single subsequent multiplication is just going to result in 0. Also, why use a long data type instead of a standard int? It's because factorials grow into massively huge numbers incredibly quickly, and using long prevents integer overflow. Step 3 is the actual engine of our program, the for loop logic. We start with int I equal to 1, and as long as I is less than or equal to n, the loop runs, incrementing I by 1 each time. Inside the loop, we run factorial equals factorial times I. How does this work in practice? The loop variable I is basically continuously updating our factorial container with the new multiplied amount. Put it all together for step 4, and here is the whole shebang, our assembled Java program. We've got our class shell, our variable declarations, our for loop doing all the heavy lifting, and at the very bottom, our systemout.println statement, which neatly outputs our beautifully calculated result straight to the console. Section 4, Code Dry Run, proving the logic step by step. Doing a dry run is absolutely critical in an interview. Let's visualize the computer's memory mutating over these 5 loop iterations. Trace it with me here. When I is 1, the factorial is 1, and 1 times 1 updates it to 1. When I becomes 2, the old factorial of 1 is multiplied by 2, becoming 2. When I is 3, that 2 is multiplied by 3 to become 6. In the 4th iteration, I is 4, so 6 times 4 makes the factorial 24. And finally, when I hits 5, 24 times 5 updates our factorial to our final answer, 120. Flawless logic. Section 5. Complexities and interview tips, standing out to the hiring manager. So what is our time complexity for this code? It's O of n, simply because we're using a single loop that runs n times, depending on whatever our input is. Pretty straightforward. And what about space complexity? That's O of 1, meaning constant time. Why? Because we only use a few basic variables to store our numbers. We aren't creating any massive expanding arrays or complex data structures. Okay, to wrap up, here are some rapid-fire, high-value tips to really stand out. Number 1, always remember to initialize your factorial variable with 1, not 0. Number 2, use the long data type to prevent integer overflow on bigger inputs. Number 3, gracefully handle the tricky edge case of 0. Mathematically, 0 factorial actually equals 1, so make sure your code accounts for that. Also, be prepared to discuss a recursive solution if the interviewer asks for an alternative approach. Always confidently state your O of n time complexity. And keep in mind, this exact question is highly favored by companies like Samsung, Morgan Stanley, and Wipro, so they will be looking for these details. So here is my final challenge to you. Practice this exact question until you can explain every single line without looking at the solution. Once you've got this down, what other classic coding problems can you completely dry run today? Keep exploring and happy coding! If you found this breakdown informative, please like, share, and subscribe to the channel. Make sure to turn on the notification bell. Thanks for watching, and I'll see you in the next video.